So, good morning, everyone. We are Harsh and Myra. Today, we are here to present our project. So, basically, our project is, as the name suggests, crop health intelligence model. So, basically, our model is made to empowering a sustainable future through data driven agriculture models and through ensuring abundant and healthy food for all the levels. So, before going to the problems, I would like you to tell us about our key stakeholders which we are featuring in our models. Firstly, the farmers, secondly, the food processing companies, and thirdly, the consumers. So let's go to the problem that were faced by the farmers. So in India, there was a problem that many farmers in India were not aware about many diseases that happens in their plant crop in their early stages. So they have the limited idea about the diseases. So they used to do or use same pesticides or same types of chemicals wherever there is any different kind of disease. There may be fungal diseases also, bacterial diseases also, or virus diseases also, but the thing that remains the same is the use of medicine or prescription. So that was the first problem that farmers are facing or we have figured it out. And secondly, if they do so, their inputs or yield may also be decreased. But what how they also become a financial stable. For example, a farmer uses a 20,000 rupees capital to buy some seeds and then sow on his land, and he also put out it hard work also into it. So by all these things, his hard work and its financial or say money can also be wasted. So this was the second problem. And the third problem is if they do so in a regular way or for a long period of time, there may be a possibility that their patch of land may also become uncultivated or say unfertile, or will become rotten. So there will be a financial losses also, like if they are planning that they can produce 100 ton of wheat, so due to this their yield is also cut off, and this may impact their budgets also. So let's move further to the food processing industry. What are the problems that are faced by the food processing industry? We have figured out the problem that was faced by the food processing industries were mainly of sorting out raw materials. For example, I will take an example of an sauce making companies. Like they uses tomato as their raw material, so there will be a high chance that these material are diseased, over ripen, and can enters without detection also. So this can hamper the production quality and also increases the financial or labor intensive. So this will also increase the financial burden on companies also. Third thing is quality compliance, that every manufacturing company has to fulfill the requirement that is set by the FSI and expert in standards. To fulfill them, there must be a model that makes them easy to do that. So there we are here to make their work easier. And then comes to the consumers. I believe that, or we believe that, if the first two stages of these food processing will be improved, then the consumers will itself get a purity or pure food or a transparency system through which they can believe that they are eating a right thing or a wrong thing. So let's move further. As previous, I have described the problems that was faced by the companies, like quality control at scale, inconsistent raw material, manual sorting inefficiency, that may be a labor intensive, error prone, there must be some error in it, and slow processing leads to bottleneck and increased operational cost, which will also reflect at the end of the secondary product price that will be paid by the consumers also. And third will be a significant post-waste harvest. For example, if I buy 100 kg of tomatoes, in which 40 kilo tomatoes will be ripen or diseased, so what I will be able to make only 60 kg tomatoes sauce. So this may dump that waste. There will be a certain guidelines set by FSI, so I have to do that operational work in it so that I can fill this criteria, which will also be a economical burden on companies for now. And this is the same thing that I have described earlier about the consumers, that adulteration risk is very high in fresh or you can say packaged food. So to create a transparency between them, our model will be there so that they can easily verify what amount or what quality does the food providing to them, or they are able to eat it or not. So let's move to our AI model introduction. How our AI model will work. For farmer, instant detection, disease detection will be done, and like for fungal, viral, or bacterial with stage-wise severity score. I am coming to the technicalities of the model, how it will work. Before this, I want to introduce how our model will provide a solution to different users. For manufacturing, there will be a automatic sort of raw material by ripeness, diseases, and damages using computer vision or production line. Mainly on the visual intelligence we will be relying on for now. Due to this, this will also reduces the waste, lowers the operational cost, and minimizes manual labor expenses, and improves overall profitability, which is the aim of any private industries. For consumers, it will be the same, that adulteration risk scoring will be done so that consumer will be aware what kind of product he or she has to buy or not. So let's come to the UI model. I would like to invite Myra to describe about our UI.
The platform has a simple web interface with three main features: user type selection, image upload or camera scanning, and a 0 to 14 scoring system. It is designed to be easy to use even in low connectivity areas. We use a universal 0 to 14 scale, but its meaning changes depending on the user. For farmers, it represents crop health. For manufacturers, it represents product quality. And for consumers, food purity and safety.
From this, like our scale is a 0 to 14 rating. I have chosen this model just to create a large integers value so that we can efficiently calculate or identify the diseased product or pure product, or adulterated food or an pure food or healthy. So let's see how our scale works. For farmers, our scale will be same as for every user. Our scale will have a same rating of 0 to 14, where 0 means highly diseased crop or crop loss imminent, and for 7 there will be a moderate disease or intervention needed, that you have to take some action instantly to prevent your crop. Or at the 14 score on our scale, there will be a perfectly healthy crop and ready for harvest. This scale must be focusing on the early disease detection, severity assessment, and tailored treatment recommendations. For processing companies, the score of 0 will be highly contaminated or diseased one, or score of 7 will be of mixed quality, that it requires manual sorting after our visual sorting also. So a score of 14 will be of premium quality, that you can use that batch directly into process something secondary product from a raw material. And for consumers, the score of 0 will be a highly adulterated or contaminated food, and score of 7 will be a uncertain purity. Like caution is advised from our side, that what you have to check about the things. Like when we come to our UI, we will show that we have also added some quiz to predict the contamination food, whether the food is contaminated or not. We'll move further into it. So, and score of 14 will be a highly pure and safe food. We use only visual media to train our model, that is images and videos only for now. And images, we use data sets like crop disease images, ripeness and food, damaged food of many crops like teas, coffees, wheat, and rice, many things. And market and consumer food photos we have also added in our model to make it efficiently work. And processing facilities visuals we will also trying to improve. And same for the video set, we have also used the video set for the same diseases of crop health disease and harvesting and handling videos, so that we are able to clarify the things. So let's see how our model will generate a score of 0 to 14. Firstly, the image input is given, then our model take the analysis, took some time to take an analysis part. And secondly, it extract the features like patterns like bacterial spot, viral decoloration, physical damage, ripeness marking, and contamination signs. And third, our model will match the patterns that it get from the input from our data set and extract features against the data set of trained pattern. Then it identify the disease type, severity level, and damage extent, and then comes to the final calculation of the model, that will be a contextual scoring. Farmers get a healthy score, disease severity plus crop loss risk will be given by our model other than from a score. This is the working of our model, how it will work. And we have also added the weightage system our model will gonna give to the each factor. For farmer healthy score, 40% weightage is given to the disease severity, how that disease is affecting the people nationwide, or you can say worldwide. For now we are only collecting the data that is nationwide. And 35% will be the crop loss risk, that disease in nationwide affected how many percent of people that become a victim of the crop loss. And third will be a ripeness level, how your crop will be ripped, how much percent of the crop is ripped by showing the visuals or the input you have put it. And 10% will be given to the environmental factor. And for manufacturers, 35% weightage will be given to the physical damage, and 30% weightage will be given to the ripeness or maturity of a raw material, and 25% weightage we have given to the contamination risk by seeing its outer skin, and 10% weightage will be given to the disease presence, that if there any disease present in it, that we can detect it visually. And for consumers, our model will be same as that. This is the 45% will be given to the adulteration risk, 25% will be given to the freshness or richness, and 20% will be given to the chemical residue indicators. We will also be relying on the chemical reports or artificial lab reports, so that our model will also work efficiently in future also. And 10% will be depend on the physical contamination. So the shared method that I have already told, and there will be a different for the different type of stakeholders that I have discussed above, that we have different scoring system also for them. Let's move further. So this is the thing that I have already discussed, that how we are gonna provide solution to the each user that we are integrating in our program. For farmers, I have already told the early disease stage will be given. This is the future road ahead. What are the plans we are going to do in our future model? Firstly, to make this model successful, we have to integrate lots of data, so that our model can predict or give us the high accuracy. For example, if I take a region wide data, like for a region it will give me about 80% accuracy, because in other region the same problem is also we discussed in a different way, or foods, or you can say methods of growing plants will be different. So for that, first phase will be of deploying phase with many cooperatives, regional cooperatives, which have handsome amount of data, so that we can use in our model to train them and help the farmers also. And in the second phase, we will be integrating with industrial sorting infrastructure and agri-based processing units, so that we are able to find out how we can put our models in their system. For industries I am talking about, so that manual sorting can be done in a efficiently and a easy way. And the third phase will be a building a network. We will be building a national digital security network connected to government agri schemes and export body. Other than this, we have also planned to include other government scheme in our model, so that we can spread awareness about our model through government schemes also, so that we can reach to the large amounts of people and help them in an efficient way. For that's it for our model. I would like you to join us in securing India's food future, and that's all from my side. Thank you, everyone. Yes, sir, we will be showing.
Sir, this is the home page. In this, there is disease severity scale and purity scale, and how is it useful for farmers, producers, and manufacturer, and how to use this app. And when we go to scanning, we can scan a picture of fruits, vegetable, or food. Like now, it is showing the disease severity scale, which is 6, and 6 means it can be eaten. And if I upload the picture of any food,
Can you upload the images of any non-edible item? Scan it.
and if I show a blank page, it will
The
say
image,
this.
it is showing that image is not relevant. Let be rotting one, yes. Yes, sir, that we have to integrate lots of data into it, as we have not able to include too much data, that it also requires some good system also for that. Yes. Yes, sir. So our computer laptops are not able to do that. Yes, we have find out the data set. The thing we are lagging in the uploading part of it. GitHub, I have heard about it, but no. Okay. We have also added the quiz over there for consumer category. As we are not able to detect the chemical adulteration in a food, so we are able to put something that will create an impact. So we have added the hygiene and handling quiz also there. Can you explain the questions also?
Like how clean is the produce display or storage area, so we can fill according to that. And then is the vendor using gloves, tongs, or cleaning handling tools, etc. like this. We have questions, and according to it, it can check the risk. Yes. Yeah.
Clean, clean.
It is showing 20. And sir, we have also included, like, if we will put our current location and we will search for hygiene restaurants, it will tell the hygiene restaurants nearby. Yes.
Yes. For that, we have not included the Google API now, Google Map API. There is data available on that, but we are deciding that firstly we have to focus on the first two categories, and then as we collect as much data, so we can make our own data set and then predict which places hygienic. So that's all from our end. Thank you, everyone. Nepali?